you'll need to turn in all the work from today. But any makeup work y'all have, I will be here a little bit third block today, and then next week. If y'all want to try and take your tests by Wednesday of next week, that'd be best. That way we don't go through too many of these lessons. However, some of this will help you with graphing. So today's lesson, now Tuesday's lesson's not going to help you with graphing, those that still take the test. But today's lesson will. We have a system of equations. What that means is we have more than one. When you get into upper level math classes, you can even have 3 equations that you graph together, and it makes like a 3-dimensional graph. Like you would have, you know how we always have an X and a Y? Well, then they have a Z that comes out. And so you have this 3-dimensional thing. We won't do that in here, and I really don't know that you'll see that in a high school class as far as graphing, but if you take a lot of college math classes, you would see that. So anyway, we have 2 equations. That's what we're going to do. Listen. Shh. Okay, if you have 2 equations, there's something that's going to happen. They are either going to be parallel, and they'll never cross. Okay, right? If you look at the ceiling, the top of the wall that's running this way, and you look at the base down here going this way, will those ever cross? No, because that one's always going to stay up there and this one's always going to stay down here. They'll never intersect because they're parallel, okay? So in math, if that happens, that would be no solution. They would never cross. But then sometimes, and I'll go over how to graph this in a second, but you'll have lines that do cross. And where they cross is where they intersect, right? Like when you get to an intersection in a highway, where the roads cross, that's the intersection, right? Same thing on this piece of paper. These lines cross, and that's your answer. So that's what we're looking at. That's the only difference from today and what you tested on. You graph them, and where they cross is your answer now. So now we just have 2 things that will graph on the same one.
So are we done with those for now?
I'm leaving that up there because I have 2 that still take the test, but we're actually going to use slope-intercept to graph and standard form to graph. Like
2 least favorite ones.
Over and over and over and over again. But as far as graphing, they're the easiest, really. Now, so I'll leave that on there to remind you, but y'all have got to get graphing down anyway. Now, let's just dive in and look at a problem. What I did today for your work, because your worksheets, they just give you a list of problems and then no graph paper or anything. So when you get your sheet, I put graphs under all your problems.
Yay.
So we don't have all over graph paper. And it's not near as many problems as what your worksheet would have. So let me get me a graph stamp out. And we'll start with our first one. And you may want to take notes, okay, to remember how to graph these, like if you want to kind of take some notes. The first problem says y equals x plus 2. And then the second part of our problem is y equals 3x minus 2. And y'all, there's going to be 2 forms. If they say y equals mx plus b, you're using the slope and the y-intercept. So we start at our y-intercept, and then we go up or down from there using our slope. Do y'all remember that? Yes, no, maybe? So let's just start with our first one. What's my y-intercept? 2. Bless you. So I'm going to go up 2. So right here, I'm going to go up 2. 1, 2. And put a dot there. And from there, what's my slope?
3, 1.
Understood 1. The number in front of x is an understood 1. So I go what? Up 1 and over 1 from that point. Up 1 and over 1. And y'all, if y'all want rulers today, I'll have rulers that I can get out. And then you just draw your line. And there you go. Is everybody good with that one? Then guess what we're going to do? The same thing again for my second equation. So where does it tell me to go?
Down 2.
Down 2. 1, 2. And from there, where am I going to go?
Up 3 over 1.
Up 3, 1, 2, 3, and over 1. I'm going to go grab a ruler. These lines are going to cross. They're not parallel unless they have the same slope. I have a slope that says 1 and a slope that says 3, right? So they are going to cross. Where they cross is your answer. And I'll give y'all a ruler when I give y'all your worksheet.
So it kind of has to be perfect or you're going to mess up?
Well, it doesn't necessarily have to be perfect, but I kind of want to see where do they cross. So I'll write this in a different, I'll do this one in this color. So I'm going to say it looks like they cross right here. That's where they're going to cross. So what's my answer? Over 2 and up how many? 1, 2, 3, 4. That's your answer, an ordered pair. 2, 4.
So your answer will be the order pair every time?
Yeah, so your answer is an X and a Y. Today we're doing graphing. Then next week we'll learn other methods of this, not even using a graph. Okay? And this is your ordered pair. Now, I'll do a few of these. We'll do our worksheet with this. And then I'll show you how to use your graphing calculator to get it as well. Because that's very important for you to know how to use it. But this is way more important to do this by hand. Now, let's do another one. Is everybody good with that one? Yeah, I'll do another one. That's fantastic.
A ladybug. Ladybug. Oh, no.
No, leave it.
Hello, ladybug.
They are everywhere.
No. No.
I'll just shake it.
He's just chilling.
I was chilling.
It doesn't want to get off the
Ladybug
phone.
on my shoulder. I was sleeping on that
He
side.
was showing y'all a graph.
I would have been. If I would have been missing it, I would have shot that.
He likes math.
He's a math.
He's a math one. Okay, here we go. Another one just like it. So I'm doing the same form. These are my favorite to graph. I think these are by far the easiest.
That could be wrong.
Well, I mean, as far as graphing though, when they're written in this form, you have your starting point and your slope. You just have to know what they are. Yeah, so we're still in the same form, and we're only going to graph this way or standard form. I'll remind you of that one in a little bit. So we're going to go up 4 for my starting point. Does everybody understand that? We have this plus 4, so 1, 2, 3, 4. From there, where am I going to go? Very good. Up 2 and over 1. All right, and then if you want, you can take a ruler. And again, you don't have to have a ruler, but it will make sure that your answer is exact. Okay. Then my other one, where's my starting point? Up 2. 1, 2. And my slope is 1 over 1. So I know they're going to intersect. They look like they might not intersect, but they are because they don't have the same slope.
So if they have the same slope, you know they're parallel.
Yeah, and we'll get to that in a minute. We haven't even gotten to that part yet. But see, couldn't you look at them? You can tell they intersect. Now, if you want to, see where do they intersect? Right here. So I'm going to say that answer is, where am I at? Negative 1, 2, 3, and down 1. So that's your answer. Sometimes they might write it as an ordered pair. Sometimes they... Oh, yeah, sorry, negative 1. Did I not say negative 1?
No, you just said
Down 1? Okay. So negative 3, negative 1. Sometimes they might write their answer like this. You could also write your answer like this. That's kind of what we'll see, not tomorrow, but our next class. We'll write answers like this. But see how either way you have an X and a Y, right? You have an ordered pair. Everybody good with that one? Yeah? Let me see what's on your sheet, because I think what I'll go ahead and do is let you do, for sure you can do 1, 3, and 7. Okay, I've only got 8 problems. So, here, I'll show you real quick. Like number 1, they're both in slope-intercept form. That's not the case on number 2. I'll go back over that in a second. On number 3, what form are they both in? They both have y equals, just like what we just did. And number 7, they both have y equals. So it's just like what, actually we can't do 7 yet. I don't know, go ahead and graph it, and then we'll see what it is for the other part. So 1, 3, and 7, so I can tag people in this to make sure to watch it. Just saying. Okay. So on this one, y'all, what was that? What are your two equations? Y equals
Negative 4x minus 6.
negative 4x minus 6, and y equals what? Oh,
Estimated, I got what you told me.
you did, and then the x plus 9. Okay. Now, for the first one, I'm going to count by ones. I know I told you can count by twos, but it can get kind of confusing, okay? Because then, like when you're trying to find out where your ordered pair is or whatever, counting by ones is best, but your graph really wasn't big enough, okay? This is just practice. If this was on a quiz or a test, I'd make sure, draw a big enough graph, or, I even have these little graph things that we could put on there to where this one is a bigger graph. I'm hoping this one will be good enough. So I'm going to go down 6, 1, 2, 3, 4, 5, 6, and then from there, where do I go? Down 4 and over 1. 1, 2, 3, 4, and over 1. When you draw a graph by hand, you're doing the best you can, right? So when I draw these, I should get really, really close to where my answer is. Your calculator is going to be exact. I'll show you that way in a little bit. But this will get you close enough. So I'm going to draw that. See, mine kind of looks like it might be off a little bit, but I'm going to kind of see, what it's close to. Then my second one, I'm going to go up where? 9. I think 1, 2, 3, 4, 5, 6, 7, 8, 9. And then from there, my slope is up 1 and over 1. Okay? So if I do that, and I know some of you counted by twos, and it's just kind of hard to see it. That's why I'm doing this.
Oh, I see what I did wrong.
And there's that graph. Now, if you counted by twos, when you go to get your answer, you still need to count by twos. And it's best probably to count like the equivalent on each one. It's easier to deal with. So how do I get to this point right here? See, mine, if you look, it's not exact. Right? But I can kind of tell, let me see about where it is. I know I'm going to the left, 1, 2, 3. Now let me go up. 1, 2, 3, 4, 5, 6. It's left 3 and up 6. So it looked like it was somewhere between 5 and 6. I would have accepted that answer, okay? Now, a graphing calculator, it's super easy to do this on a graphing calculator. It will give you the exact answer. Please remember, I only have 2, so don't come in here like if there's a test day expecting like if 10 of you need to borrow one. I've only got 2. If you ever want to borrow someone's, because you don't have to have that in this class, you can graph this way, or you can borrow a sibling's or a friend's, okay?
What time is it? Not what time. What's today's date?
Oh, today's the 28th. Bryson, did you have a question?
Can I ask you if I got something right?
Yeah, let me pause this. Okay?
Okay.
This. So he got negative 8, 3. If I plug in a negative 8, would my y be 3? No. If I plug in a negative 8 here, it's going to give me 1. So is that the right answer? No. You can plug them in and check your answer. In ACT prep, or when they come and do those like classes, they call that plug and play. Okay, what did you say you got?
Negative 4, negative 3.
Negative 4, negative 3. Let me plug in a negative 4. If I do negative 4, that becomes a 4. 4 minus 7 is negative 3. If I plugged in negative 4, I got negative 3. Let me try it again down here. What's 2 times negative 4? Negative 8. Negative 8 plus 5 is negative 3. Her answer works on both equations. Her answer is correct. So they call that plug and play. It's always a good way to check your answers. Big hint. On this test, when it's multiple choice, or on the quizzes when they're multiple choice, you can plug and play any of the answer choices and see which ones work. Okay? So there's lots of ways you can check your answer. Some of you just don't want to take the time to do that. It's very wise to graph them and see what you get, then go back and plug in the answers. And I'll do that again in a second just to show you what I mean. Go back and plug in the answers. If they work, you're right. That's a way to make sure you're right. So, y'all want me to do number 7? Okay, I'll wait a second.
I got me.
And then I'll show you again what I mean by plug and play. Everybody should be done with that one. Shh. All right, everybody, hold on. Y'all, back to me. Just let me go over it, okay? Everybody pay attention up here. Shh. So we have -7 is my starting point. I'm going to go down 6. One more is 7, and I'm going to hope that that's kind of close enough. From there, I'm going to go where? Down 1 and over 1. That's my slope. So I'm going to go down 1 and over 1. It's kind of hard to tell when I'm off my chart, but I'll draw my line, and let's see. Then I have up 5. 1, 2, 3, 4, 5. And from there, I'm going to go up 2 and over 1 right here. And if I connect those, it should be there. So, again, because I went off my chart, it's probably not going to be exact, but it looks like I'm going to go left 1, 2, 3, was it 4?
Yes, ma'am.
And down 1, 2, 3. So see, I'd have to kind of guess where it is. That's why I'm going to show you how to do it on your calculator as well. All right, but if you had this, as your answer, that would be very, very close. I would go with it. All right, but for you to check and get an exact answer, what I was saying about plug and play is that's an X and that's a Y. What do I have right here? So if I plug them in, it needs to be equal. So if I plug in my -4, I'm going to pick my bottom equation. So -3, and then over here I'll plug in that -4. Do these two things equal? What's -8 plus 5? -3. Then yes, that is the right answer. And a lot of times on these, they're going to be multiple choice, okay? So you could kind of guess where your point is. Now, let's graph another time. Actually, we'll pick up with our graphing calculator real quick. Let's do a couple, and then I'm going to show you how to graph the other ones. I need to see what time it is. Oh, yeah, we're doing fine on time. Okay, if you have a graphing calculator, I'm going to do a different problem. It's not on our paper. I'm going to get y equals 2x and y equals -2x plus 8. I'm going to graph those. The only time you can use your graphing calculator is if you have y equals. If they're not in y equals, you can always rearrange it though. So really, anytime you can do your graphing calculator. You just have to be good enough at rearranging your equation. But on a lot of the problems, they'll be like this. They say y equals, so what am I going to press on my calculator? The y equals button.
I don't know what
It's at the top left. Top left, it says y equals. Yes?
Okay, I used my calculator in the bedroom one day and I forgot it in there. And
Your graphing? Graphing calculator?
No, it's my calculator.
Oh, your regular? Oh, I don't know. If I see one, I will let you know. But there's one back there on that cabinet. Okay. Anyway, so we have y equals. So I'm going to type in the two things that it's equal to. What's the first one say? Y equals 2. And your x. Your x is this button right here. It says xt theta n. That's your x. And then I'm going to press enter because I'm going down to type in my next one. What does my next one say? -2x plus 8. Now, y'all, just about every time, you can just press the graph button. But if you have borrowed someone's calculator, especially someone in an older class, press Zoom 6 first. So yours may be fine. I'm going to have to press Zoom 6. There's a window. This is a window right here on your calculator. And as you get older, you'll be able to change your window. Zoom 6 takes you to just a normal standard viewing window is what they call it. So just everybody press Zoom 6 for now. Zoom 6. Here's my two graphs. Now, you would still have to plot these points on paper. What I will not accept is you going like, it looks like that. Like, that's a big 0 for me, right? I can't tell where any of those points are. Does it look like that? It does look like it, but will I accept this? Absolutely not. Okay? If you want to find points to plot these, you go to this table, second graph. That's a little table button. And guess what they give you? A big list of ordered pair. Okay? Second graph.
Like 2, 5. Is that what
Yeah, so there's all different points. All different ones. So notice I have several ordered pairs.
Wait, what did you just press?
Second graph. This yellow button and then the graph button.
Alright, got it.
Okay? Now, oops, here it is. The way to do this is, see how they have y1 and y2? That means your first equation and your what? Second equation. So you could graph both of them. I don't care what values you pick. If you do this. You don't have to do this. You don't have to use this. And let's see. It would be, what is my x is 0, y is what? 0. I'll plot that point. And then let me plot one more. If x is 1, what's y? 2. Okay, I'll plot that point. And then I'll draw my graph. Okay, see now I used my calculator and it told me where to plot my points. That's fine. I can tell where my line goes. Then let me do the other one. I don't want to use 8 and 6. Those are kind of big numbers. If x is 2, what's y? 4. So I'm going to go over 2 and up. 1, 2, 3, 4. That's my point. And then let me do one more. I'm going to go over 3 and up 2. 1, 2, 1, 2, 3, and up 2. And then I would know that's this line. Okay? So that's an exact graph. You don't have to use your calculator to do that.
So that's the graph.
That's-
the equation you put up there.
Yes. So, or to me, I would rather just graph these, but say I don't know where they cross. That's when I would use my calculator. So let me show you that now. Press graph. Everybody go back to your graph. I want to find where these cross, where they intersect, right? If you press graph, it says error.
Yeah, keep doing it.
Go back to y equals. What does it say? Y equals,
The first one's 2x, the second one's negative 2x plus 8.
and you didn't put minus 2x plus 8. You put a negative.
I put a negative.
Bring it here and let me see. Maybe I'll make sure your stat plots aren't on, but they shouldn't be. 2x, negative 2x plus 8. There it is.
But like it goes in there, it says error usually.
It's saying, do you have something else? You had this enter down here.
Shut up.
I did?
Yeah.
What is that?
That's an integral from calculus, a derivative. Anyway. Oh my word, you have all kinds of stuff.
It's probably from being in my backpack and it keeps hitting buttons on me.
Yeah, it's just random. I didn't even know it did integrals on here. And now let's try and graph.
Stop when he says it there.
Katie, please say that.
Okay, now, oh, you're welcome. So I've got my two equations. Now we're going to calculate that intersection. So do y'all see this little trace button? How above it in yellow, it says calculate? So you're going to press second calculate. And guess which option we're going to pick? Intersect. So again, it's second trace or second calculate. And we're going to go down to where they intersect. Okay? Press enter. And all you have to do is press enter 3 times slowly. Like enter, enter, enter. It's helping your calculator calculate it. And what does it tell you your answer is?
2x plus b.
No, it's 2
X equals 2.
and y equals 4.
Y equals 4.
Yours doesn't look like this?
Well, it definitely does. No, ours said x equals 0.
I hit
and
my
y
what?
equals 8.
I hit enter, and then I was like, no, I was supposed to hit it 3 times, so I just did it twice,
Oh, okay.
and then it didn't work.
Oh.
Should I hit enter again?
Maybe. That's why I'm saying don't press enter like enter.
We're gonna have to have a
Because-
calculating class.
Because it's not gonna, your calculator's not gonna have enough time to process it. Press enter, press enter, press enter. So, cause let it count, give it a second to calculate those values. Did it work that time? Yeah. So you probably just pressed it so fast that it didn't, like, accept it 3 times or whatever. So that's your answer. Look how you can check your answer. Say that I graphed it on my own, and it was crazy. Like, let's go back to what number was that one that we couldn't see? Let's go back to number 7. I graphed it, and I can't tell where my answer is. So guess what I can do? I could type these in my calculator. Let's try it, okay, and find where they intersect. So go back to y equals. Yeah, press y equals, and then you're going to clear those 2 out, and you're going to put your 2 new ones in, okay? Because I couldn't quite tell where the answer was, I'm going to let my calculator help me. So I'm going to type in negative x minus 7, and then I'm going to press enter and go down to 2x plus 5. And then what are we needing? A graph. So we're going to press graph, and it's drawing our, 2x plus 5. This was number 7 on your sheet. And press graph. Because, see, mine didn't look quite right, so I need to find where the answer is. So I'm going to press what? Second trace, because I'm going to calculate. What am I calculating? Where they cross, where they intersect. Think of streets. Streets cross, they call that a what? Intersection. Okay, so we're going to find where they intersect. Now it needs us to help it calculate. Enter. See, it's asking little questions. And then enter. And now it is negative 4, negative 3. So see, mine looked like it was that, but I couldn't quite tell for sure. So does everybody understand this? Does everybody like this? Yeah, this is...
Yeah, it's easy.
Calculators are great to help you. To me, it's easier to graph on the paper. Yeah, but this is easier to calculate where they intersect. All right? Everybody's good with that? Yes. No. Maybe. No. You can come see me if you need calculator help. Now, we're moving on. And the thing about these, I can't type both of these in my calculator. Why not?
Because
It doesn't say y equals. I'm going to show you how to graph these on paper. This one says y equals. That's great. This one does not. Or you can rearrange your equation. Raise your hand if you would rather. Here's your 2 options. You can either rearrange the equation. That means move what's over here. The other option is to find your y-intercept and find your x-intercept. Raise your hand if you like option 1.
I don't even know.
I don't know.
It's
Use your
moving
calculator.
Raise your hand if you have no idea what we're doing.
Katie, raise your hand.
Okay. Okay. Let's try. Let me just try a problem that doesn't have both y equals.
Katie, you know what's going on.
Well, just wait. Let me get everybody up to speed.
I think Katie's
Okay.
hand moved.
If I have,
Katie,
I don't want that one.
ask Katie.
Here we go. Y equals negative x minus 4. This one is nice. It's easy to graph either on the calculator or on my graph paper. Either way. But my second equation they give me says 4x minus y equals negative 1/4. I'm trying to see how they... Do y'all just want to solve for y? Is that what everybody... We'll go for it.
You know how we move the stuff over?
Yeah. So, on this one, this one's great. I can type this exactly as it is. Let me highlight it. Negative x minus 4. That one's good. On this one, what do I need to move to the other side?
The 4.
The 4x. So I need to subtract the 4x over here. Okay, so I have to bring down everything else. What does that say right there? Negative y. That's going to be a problem. We'll fix it in a second. Then what do I bring down next? A negative 4x and a negative 1. Negative 4x minus 1. Any questions on that? All I did was when you move that term to the other side, because it's in standard form, you just put this over here and make the opposite of what it was.
And it always goes in front of that?
Your x always comes first. If you want slope intercept form, what do they have first every time? Their x. So basically, I don't even write this step because in my mind, I just think, I'm just going to make that a negative 4x. Now, what's your problem with this equation?
It's negative.
It's a negative right here. If I change that to positive, what else do I have to change? Everything. I have to change everything.
Just turn positive.
Yeah, so if they're negative, they're going to turn positive. If they were positive, what would they return? Yeah, you're just going to take the opposite of everything. If I do that over here, I have to do it over there. It's basically like dividing by negative 1. Okay? So, all it would be is y equals 4x plus 1. Is everybody good with that? Yes, no. So do we like this method, just
No.
rearranging? The other, I think this, to help us with graphing on the calculator, this I think is going to be the way to go. Okay? And it keeps everything graphing the same. That way we're not using both methods the whole chapter, right? Because I think that's what confused some of y'all on your test. So let me graph them, or you can graph it on your calculator. I think it's easier just to graph it like this. I'm going to go down 4. 1, 2, 3, 4. And then what's my slope? Negative 1. Down 1 over 1. Okay? Is everybody okay with that? If not, you need to speak up. Okay? And I've got to graph both equations. Hold on. And I draw my line. Okay? Now my other one, where's my starting point, Aston?
It's it. You go up. Wait, no, up one. I was looking at one.
Up 1? Yeah. So I'm going to go up to my 1. And then what's my slope?
You go up 4 over 1.
That's right. 1, 2, 3, 4, and over 1. And then I'm going to connect those dots and draw my line. Okay, this one I can pretty much tell exactly where it is. All right, I get the answer of negative 1, 2, 3, and negative 3. Do y'all think that's right? So, I can do this several ways to check my answer. Let me plug it in. If I plug in negative 1, what's 4 times negative 1 plus 1? Negative 4 plus 1 is negative 3. Is that answer right? Yes. Another way to check my answer would be to what? Graph it, okay, and see. And you're going to hope that you wrote your equation, your new equation right. Okay, so if I graphed it, it's negative x minus 4 and 4x plus 1. Do I need to stop for a second? Negative x minus 4 and 4x plus 1. Again, you don't even have to have your calculator to do any of this, right? We just found our answer without it. It's just a good way to check it. Negative x minus 4 and 4x plus 1. We're going to press graph. Looks a little bit like my graph. And then what am I going to press? Second, trace. Number 5. Enter, enter, enter. And what does it tell me? Negative 1, negative 3. So I'm pretty sure that answer is right by now, right? I've checked it several ways. Okay. How do we feel about these?
Horrible.
Pretty good, horrible. Okay, let me do another one where I rearrange my equation. Okay, let's see. Oh, y'all, and notice we've had one solution every time, right? Where do they cross? At one point. But I told you what happens in a minute is we could have parallel lines, right? And where are they going to cross? Never. So there's no solution. And then there's a third option. I'll go over it in a minute. But let me do one more. I'll do y equals 1/3 x plus 1. And I'll do 3x plus y equals 11. So my first one's easy to graph, right? I'm going to go ahead and graph it. I'm going to go up 1. Oh, I wish I wouldn't have had that 11 though. Oh well. We'll just go with it. Yeah, this is not on your sheet. I don't think it's on your sheet. I went up 1, and then from there, I'm going to go where? Up 1 and over 3. Up 1, 1, 2, 3. And I'm graphing this. Probably not exact. Now for my other one, does it say y equals? No, I'm going to rewrite it right here. 3x plus y equals 11. What's over there with the y? The 3x. So that's all that I need to move. That was our last problem. So I need to move it to the other side. I would subtract it over. Or remember I told you you can just, it's negative 3x plus 11. Move it and it becomes the opposite. Negative 3x plus 11. So where's my starting point on this one? Way off my grid. That's okay. We'll go with it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then from there, where am I going to go?
Up 3.
Or down 3 and over 1.
Wait, where's that?
Well, remember it didn't say y equals, so you had to move it. So you're going to go down 1, 2, 3, and over 1. And graph this one. And I have a feeling that we might not can tell. It looks like it's right there. Okay? So I'm just gonna guess that that's what it is. It looks like it's 1, 2, 3, and up 2. Well, how can I check? Well, one way I can plug it in. Okay? If I plug it in, I get negative 9 plus 11. What's negative 9 plus 11? 2. If I plugged in my 3 for my x, I would get 2 as my answer. I plugged in 3, and I would get 2. Another way to check our answer, let's graph them on the calculator. Y equals, my first one, was 1/3 x. You just put 1/3, 1 divided by 3, plus 1. And then my second one is negative 3x plus 11. And if I graph, there's my answer. Second trace, number 5, enter, enter, enter. And it also tells me what? 3, 2. All right, so we can check our answers. That one also had one solution. Now I need to show you, this is our possible choices, okay? Because you might have something a little bit different on your paper. I'm about to give you time to work on those. Notice this is every problem we've done so far. They crossed. One solution. This one was the one we've talked about several times. If they have the same slope, they will never intersect. Okay, so it's no solution because your solution is where they intersect. Okay, the only other option is if they gave you the exact same equation twice. If they give you this equation and you graph it, okay, let's just say this is the graph, and then they give you this equation and you graph it, what is that? It's the same equation, so it's the same exact line. Where do they cross? At every single point. So they call it infinitely many solutions, okay, because it's the same line. You've just graphed it on every point. That's kind of weird, I know.
So if there's the same.
So if you get the same exact line, so if you rearrange it for y equals, and it's the same line, it's infinitely many. Or, when you might type them both in your graphing calculator, it's only going to graph that same line twice. So you'll see infinitely many. Does this make sense? Yes, no? That's kind of what the back of your sheet is asking. I know you haven't finished all the ones on the front, but it says tell whether the solution has one, infinitely many, or no solution. So your number 7, you've already graphed it, but what else are you going to write? One solution. You don't have to do that on the front of the sheet. So number 7, it says to graph it and then tell how many solutions it has. That one has what? One solution.
I can only graph number 7 on number 5.
That's fine. Just do like a little arrow. That's fine. Now y'all are going to do the rest of them. You're going to spend the rest of class graphing these others. If you want to, yes. Here you go. If you want to check your y equals, like say on number 2 and 4, you solved for y before you graph, then you can check with me up here.